Welcome students, welcome to Dnyanjyoti education. Today we are going to see one of the very basic topic which we know by the name called as insolation. Okay, if you see in the present context, we are government of India and all the other world is actually trying to harness one of the most abundant available energy, that is the sun's energy. Okay, and regarding this we must have an understanding that what is this sun's energy, what is the term, that is insolation. So we are now going to study this topic in the nitty and gritty, and we are going to understand all the related concepts and terminologies regarding it. Okay, so let us begin. Now, insolation, let us first try to decode this word insolation. Okay, now if you see insolation, it is made up of actually three small words, that is incoming solar radiation. Okay, so it's an energy, it's the sun rays, it's the sun's energy that is received by the earth, that is coming from the very far located and one of the most important stars of our solar system, that is the sun. Now this insolation is insolation can be actually understood by understanding its few characteristics. Let us see. So this is sun is the primary source of energy. Now this word, though it is a very commonly used word, but it holds some meaning. Okay, so what do you understand by primary source? So it's the first source, is the most fundamental source. It is the source through which living organisms, all the atmospheric activities depends on. Okay, now for example, if we see clouds move from here to there, plants are growing, these are some processes that definitely needs energy. So where do we get this energy from? And that would be nothing but the sun's energy. So it is defined as primary source of energy. Okay, now if we understand, there are two kinds of system. Okay, in physics definitely we can do have a background regarding this. So in thermodynamics especially, okay, so where we actually design a system, for example a piston moving in a cylinder, it's a kind of system. So two system when exchanges something, then in that context they are known by two words, that is if they exchange a thing then they would be known as open system, but if they do not exchange a thing then they would be known as a closed system. So in terms of primary source of energy which is received from the earth is a system itself, and definitely we are receiving energy from the sun. So in this context earth is defined as open system. Okay, if I want you to give another perspective regarding this, if I say that regarding material, okay, do earth receive any material from the sun, then the answer would be no. So in regarding this, earth would be defined as closed system, but in terms of energy earth would be defined as an open system. Second, sun radiates its energy in all direction into the space, which will be in the form of short wavelengths. Okay, just understand this. Okay, now here there is one important law that you should know, this which is known as Wein's law, which is known as what? Wein's law. Okay, what does Wein's law says? Wein's law says the higher the temperature of a body, shorter will be the wavelength emitting from it in the form of energy. Okay, now if you see sun has tremendously high temperature. Okay, especially its coronal part has higher temperature. Now due to the such high temperature, the energy which is coming in the form of electromagnetic wave, in the form of radiation, this will have very short wavelength which will be of very high frequency, and therefore sun radiates energy in all directions in the form of short wave. Okay, which law is obeyed here? Wein's law. Okay, comparatively if we say earth is having temperature lower than the sun's temperature, so definitely the radiation or the wavelength that earth will be radiating will be in the form of long wave, again obeying the Wein's law. So one important law we can definitely understand here. Now to have an idea how much the earth is actually harnessing, how much amount of energy is the earth actually absorbing from the sun, we can have a small equation here, that earth's surface receives only a part of this radiated energy. So it receives how much? so it receives only 2 units out of 1 crore units, that is units of the energy radiated by the sun. So in such a small amount, the whole earth is trying to sustain itself. You can just imagine what is the total amount of energy that will be received from the sun. So every other scientist and every other country in the world are in such a prospect that definitely we should harness the maximum possible energy, because it would be literally, it would be available to us for infinite amount of the time. Okay, moving further, let us understand more regarding insolation. Okay, the energy received by the earth's surface in the form of short wave is termed as incoming solar radiation. This is how we can define, and this definition will be complete when I will just insert that energy received by the earth's surface in the form of short wave electromagnetic radiation is called as insolation or incoming solar radiation. Then my whole definition will be a complete definition. Definitely the energy that we are receiving from the sun, it will be in the form of visible light and will in the form of wavelength which is below visible light. Definitely you need to now learn here what do you understand by light spectrum. Okay, so in this you will understand there are various frequencies in which light exists in different forms. For example, X-rays, gamma rays, UV rays, infrared, visible spectrum. So the energy that we are getting from the sun will be mostly in the form of visible light spectrum as well as the ultraviolet radiation. Okay, now the earth absorbs shortwave radiation during the daytime and reflects back the heat received into the space as a long wave radiation. This we have already seen in the previous slide. Here I will again reiterate, it would be Wein's law, but this re-radiated heat, this re-radiation energy will be in the form of infrared radiation. Okay, so just understand the earth is receiving in the form of visible light spectrum and UV light spectrum, but what is re-radiated back will be in the form of infrared radiation mostly. Okay, so here the re-radiation power of the earth is also known as albedo effect. It's another important unit, that another important topic that we must be aware of regarding this competitive examination. So further we will discuss it in our further videos. Let us now concentrate on only on the insolation. Okay, we have already seen one unit. We have already seen a measurement that only 2 units out of the 1 crore units emitted are actually absorbed. An approximate figure scientists have given to us. Further to add up, we can understand how much amount of energy does the earth actually receives. So it is expressed in the unit called as Langley, given by a scientist name. So what do you understand by Langley? Langley is nothing but short of calories per square centimeter per minute. Okay, so to just express this bigger unit, we call it simply as Langley. If to give you a small understanding, if I take an area of 1 centimeter square, if I take an area of 1 centimeter square, approximately on this 1 centimeter square area, approximate value of Langley would be around 1.94, and this 1.94 is nothing but 1.94 calories per square centimeter per minute, which will be approximately taken as 2 Langley for calculation purpose. And what do we need to approximate it for? We need to approximate it for to study the heat balance of the earth, which would be another unit that we can be extended further from the insolation. Okay, so we have got 2 important concepts regarding 2 important units of measurement, that is 2 units of energy is only received after the 1 CR unit that is being received, and approximate energy will be around 1.94 calories per square centimeter per minute, that will be Langley. Further, we need to understand there is one more unit which is approximately same as this, which is called as solar constant. Okay, now what is solar constant? To understand this, we need to actually just get into this figure. Now suppose this is earth, okay, and envelope of the gas around this earth is called as actually atmosphere. Okay, on the top of the atmosphere, if I take an area of 1 centimeter square, how much amount of energy do we get? it will be 1.94 Langley, as we have already seen. It can be expressed into another figure also. Okay, if I just take this area, not 1 centimeter square, but around 1 meter square of area, I would be taking it, I would be getting another important figure, that is 1366 watt per meter square of energy, which will be called as solar constant, or I can express it as 1.36 kilowatt per meter square. To get it approximately correct, I can even say it 1 kilowatt per meter square. So what is 1.94 Langley? What is 1.4 kilowatt per meter square? It is nothing but the amount of energy expressed differently that the earth is receiving from the sun. So definitely we can understand, remember this figure. This figure is also known as the solar constant. This figure is also known as the solar constant. Okay, so we have this different units that you need to remember. Okay, these units, though they are differently expressed, but they are the same, or they are the one and the same thing, that is the amount of energy that the sun is receiving on the amount of energy received by the sun on the top of the earth's surface. Moving further, we can definitely have an understanding of what do you understand by sunspots. Now see, if you just look at this figure, okay, from this you just can understand what do you mean by sunspot. So this is the glaring sun, the bright star, okay, and on this bright star you can see some of the spots which are black in color. Okay, these are nothing but sunspot. So what are sunspot? To give and explain you through with the help of diagram, these are the areas where relatively temperature of the sun is relatively low compared to the other points present on the sun. These are nothing but known as sunspot. Now let us go through the PPT and we can understand. Sunspot, some are large as 50,000 km in diameter, and approximate area are the areas that appear dark on the surface of the sun, and the surface is called as photosphere. They appear dark because they are cooler than the other parts of the sun. Okay, cooler means relatively temperature is low. Okay, this will be having a very high temperature. Of course, we cannot actually go and touch those parts, but definitely we need to understand that relatively their temperature is lower compared to the other parts. Okay, however, the temperature of the sunspot is still hot, around 6005 degrees Celsius Fahrenheit. Okay, and photosphere is a visible surface of the sun from which it emitted most of the sunlight that reaches the earth directly. So you need to understand that photosphere is actually that part from where we get the energy. And this is a small introduction about sunspot. Of course, we just need to have a brief idea what do you understand by it. Now there is another concept, okay, which is called as coronal mass ejection. Okay, if you just see here, these are nothing but the blue lines, the yellow lines represented here are nothing but coronal mass ejection. Okay, the name itself is difficult, but the concept is not. Now let us understand. Solar flares are sometimes accompanied by coronal mass ejection. Now what do you understand by solar flares? Okay, now to understand solar flares, you need to understand these are nothing but we can say exploded part with a very high speed when sun's magnetic lines suddenly reorganize. When sun is trying to readjustment something, there is a kind of explosion and we do get solar flares. Okay, and from these flares, coronal mass ejection are the huge bubbles of radiation and particles from the sun's corona, the outermost regions of the sun's atmosphere. So understand, we have introduced here two things, that is the photosphere, which is the surface, and the outermost, which is the corona. So definitely these coronal mass ejections are from the solar in the form of solar flares are coming from the corona, and they can trigger intense light in the sky on the earth, which will call an effect called as auroras. Okay, this effect are very important. If you see, okay, so if you see this, you can just observe this green portion. This is known as aurora Borealis, and on the southern side these are known as Aurora Australis. Okay, so there is a definite way in which these are formed, the Borealis and the Australis. Okay, to give you in a very shortest possible understanding, you need to understand these are a very beautiful patterns that are ionizing gases in which can be observed in the higher latitude countries such as Norway or from the Antarctica, and this pattern can actually be observed in the sky. These are due to this coronal mass ejection. Okay, now moving further, if we see the amount of energy received from the earth, received from the sun on the earth definitely varies due to different aspects. Let us understand. The solar output received at the top of the atmosphere varies slightly in an year due to variation in the distance between the earth and the sun. So do the distance vary? Of course the distance is going to vary. Now see, sun and earth will sometimes have distance very far, or distance will be greater, and sometimes the distance will be lesser. The farthest point from the sun where the maximum distance between sun and the earth, or the point at which earth will be farthest from the sun, is called as aphelion position, which will be around 4th of July. And when the earth is nearest to the sun, it is called as perihelion position, which will be around 3rd of January. So earth actually moves in the form of elliptical orbit. Earth actually moves in the form of elliptical orbit. This is what you have to understand. So whenever the distance will be shorter, earth will receive high amount of energy, and whenever the distance will be longer, earth will receive low amount of energy. Okay, this one thing you need to understand. But this is not only the factor. Okay, if you see, January we have winter season, but earth and the sun definitely the distance is lesser, so we must have what? We must have huge amount of heat. So it should be summer season, but in January we have winter. So what are the other factors that need to be understood here also? In the same way, in July we have that sun we have sun and earth, the distance is maximum. We should actually have winter, but it is a season of summer season. So what are the other factors that need to be actually studied? It's a matter of further understanding. It's a matter of another topic that need to be brainstormed. Okay, so coming to one of the last point of this video, we can understand what are the factors that influence the insolation. Okay, so these are the 4 standard factors. Okay, first is rotation of the earth on its axis, the angle of incidence of the sun rays, duration of the day, and transparency of the atmosphere. Of course, we are only going to discuss these 2 factors. Why? Because if you see clearly, these factors are defined as very less prominent or very less important factors that actually influences the insolation. But the 2 most important factors we need to understand is rotation of the earth and the angle of incidence. These are definitely self-explanatory. Larger the duration of the day, larger will be the heat received. And here, more transparent will be the atmosphere, more energy of the sun will receive the earth. Less transparent, or if more cloudy, more dust particles present, definitely we will have less amount of energy from the sun. So these 2 factors we are going to see in detail further. Now first factor, that is the rotation of the earth. Now see, earth has 2 important movements, that is rotation and revolution. Now if we see, earth axis is not a straight axis, but we can say it's a tilted axis. Tilted axis, tilted by around 23.5 degrees. And if we see this reference, this angle will be 66.5 degrees. Okay, Now due to this tilted axis rotation, due to the axis which is 66.5 degrees tilted with reference to orbital plane, the energy received from the sun on the Earth's surface varies. Okay, now how does this variation occur? Okay, now just to give you a brief idea, you need to understand that this varies from equator towards the poles. So here maximum energy will be received, but as we move further, the energy will decrease and decrease. It is due to the tilted axis. Due to this tilted axis, we definitely have seasons, and therefore this seasons also gives variation of insolation on the Earth's surface. Right now we need to understand here only, because we need to imagine this concept with a very important topic, that is apparent movement of the sun, which is very important to study the seasons, how does they occur, how does the wind shifts on the Earth's surface. So one of the factors is rotation of the Earth. Further, another important factor will be angle of incidence. Okay, now if you see this diagram, you will understand that the beam of light which is incident on the equator, we can definitely understand this is equator, the middlemost part, and the beam of light which is actually incident on this area which is on the higher surface. Here we have more area to be covered, and here we have lesser area to be covered. Therefore, same beam of light will need to heat up more area, and same beam of light will need to heat up lesser area. So definitely it will have a higher temperature and it will have a lower temperature. So this is another important factor, that is the angle of incidence, that is the latitudinal extent. We can definitely reword it. So here we will have higher temperature and here we will have lower temperature regarding our distribution, the heat received from the sun. Okay, now again we need to see a few points, that is, if we spatial distribution of insolation on the Earth surface, here space means according to area. Here space means according to area. So few facts we need to remember, which are very basic and which are actually oftenly missed out by the students, that insolation received at the surface varies from around 320 watts meter per square in the tropics. In the tropics means around Cancer and Capricorn, and in the poles we have around 70 watts meter per square. So definitely this figure needs to be remembered. Maximum insolation is received over subtropical desert. Okay, now there is another reasons why subtropical deserts have maximum insolation, but to give you very briefly, you need to understand these are the areas which have no clouds nearly all year. Okay, so where cloudiness is least, this is the reason. Okay, this is a very briefly stated, but there is a specific reason which I will be discussing in further videos. Okay, and then we have equator receives comparatively less insolation than the tropics. So here you need to understand, though equator is in the middle of the Earth, but it received less insolation than the tropics. Generally at the same latitude, insolation is more over continent than the ocean, that is land will be heated more than the ocean, and in the winter the middle and the higher latitude receives radiation will receive less radiation than in the summer. So situation is differently in the middle and the higher latitudes. You can approximately say it around 40 degrees latitude up and above. Okay, so around 40 degrees latitude you will receive less radiation than in summer compared to the winter. Okay, so that is what you need to understand. So these were basic points regarding insolation. We just need to understand the concept of insolation here. Definitely we will have more clarity on this topic when we further study what do you understand by temperature and temperature distribution, which will be based on this topic called as insolation. So thank you guys.